Okay, for the next part of the question, we have the equation of one of the asymptotes of f of x is x equals 1. Well, that's easy enough, right? You didn't need to be told that. You can see it over here. X equals 1 is going to kind of cause it to break. It's an asymptote of this hyperbola. Write down the equation of the other asymptote. Now, I've put for reference here that we already know what the inverse function is, which means for the inverse function, we know that there is an asymptote at x equals 1. There it is. Now, remember, for inverses and functions, they are a reflection about the line y equals x, and that idea of what's x is y is x idea. So if the inverse has an asymptote at x equals 1, then the original must have had an asymptote at y equals 1, right? They match. And of course, the same is true to go the other way and to say if the original function has an asymptote at x equals 1, it means that the inverse has an asymptote at y equals 1. Interesting, right? Now, you could play with this algebraically, and sometimes this is worthwhile, so I'm going to go through it here as well and say, you know that y equals, great stuff, y equals x minus 5 over x minus 1. Okay, now it would be nice to put that in the form y equals a over x minus p plus q, because then we can read off our asymptotes and it's in a form that we're possibly more familiar with. So let's do some algebraic manipulation and say, well, x minus 1, if we want to change from the one form to the other, it means we need to split one term into two terms, which means we must have an x minus 1 somewhere that we can cancel to create the second term. So let's write this as x minus 1 because that's the form we want. And that's not quite the same as the original numerator. We'll have to subtract 4. Okay, now those two are exactly the same, right? Y equals x minus 5 over x minus 1 is the same as y equals x minus 1 minus 4 over x minus 1. Now, what's great about that, I know, great, isn't it, is that we can split that into two fractions. So we can imagine this is the same as x minus 1 over x minus 1 minus 4 over x minus 1. Pause and just check that you're happy with that idea of the denominator is the same. Instead of turning two fractions into one fraction or two terms into one, we've done the opposite and split that fraction. Now we've done it with a particular purpose in mind because x minus 1 over x minus 1 is just 1, and this is minus 4 over x minus 1. Now, maybe as a last step, we just write this the other way around, so we have it in that form we used to, plus 1, and now we can see more clearly that we have the one asymptote and the other asymptote, and it looks just like the hyperbola that we would expect. Right, it's going to be one of those, and we've got x equals 1 over there and y equals 1 over there. So can't help but just go one step further and say, interesting now how you can quite clearly see that if you took the inverse of this function, it would just be itself again. Okay, remember that an inverse is just a reflection about the line y equals x. So for yourself, draw that and convince yourself why the inverse is just the function itself. It would look the same. Okay, there was quite a lot going on there, but all fascinating stuff, isn't it?